Hello everyone. In this lecture I will focus on state machine and basically there are two types of state machine, Mealy State Machine and Mealy State Machine. So we will focus on Mealy and Mealy State Machine also. So before going on this, let me tell you what is state machine. State machine actually is a circuit which are used to model sequential circuits. Fine. So state machine is not like conventional machine that you saw in your daily life like fan, AC. This is not that kind of machine. It is circuit basically which is used to model sequential circuit, and we call it machine because machine is something where you got output for given input, and here also we will get some output for given set of input. That's why we call it machine, or we call it circuit also, no issue. Okay, so to design any state machine there are few terms that you should know. They are state diagram and state table. So what is the normal procedure to design a state machine is, to design any state machine, first you need to know state diagram. From this state diagram we will derive our state table. Then from this state table we will from this state table using K-map or any other method we can find relation between input set and output inputs and outputs, right? And then if we have this relation, using this relation and using logic gates, flip flops, we can design our state machine. So now depending on the what state machine you want, Murray or Mealy, we can get our state machine. So this is normal procedure. And suppose if state diagram is not given directly, if state table is given, then you can use state table directly to find relation and then design state machine. So this is normal procedure. So you should know what is state diagram, what is state table, and I will first focus on state table and then I will tell you about state diagram. Fine. So what is state table? State table is basically a table that gives input and present state at one side, next state and output on other side. And this combination, input and present state, it can be treated, remember it is not input, it can be treated at inputs. Next state and output can be treated at outputs, but these are not output. Input and output is different only. So suppose let me give you some random example of state table, and then from this state table I will draw state diagram. So suppose this is the input to this uh, state machine is, or some circuit is there, or I need something for which inputs are x. Present state is represented by qa qb, next state represented by qa plus qb plus, and output is represented by y. Now remember one thing here, if I am using two states, because here present states are there, right? So if I use two states qa and qb, that means this state machine requires two memory element or two flip flop. That means number of states will define or will decide number of memory element or flip flop used. So here how many states are there? qa and qb, two states are there. So we need two memory element to design this. Fine. So this is state table, and state table is nothing but set table that represent input, present state, next state and output. Now let's come to state diagram. Just showing this relation that we have in state table in a pictorial way, we can use state diagram. So state diagram is nothing but it is relation between state diagram is nothing but relation between uh, input, present state, inputs present state, next state, and outputs. So pictorial representation of relationship between inputs present state, next state, and output is known as state diagram. Fine. Now we will draw state diagram for this given state table. Okay. So just remember one thing. Number of states, total number of states will be 2 raised to power number of state variables, total number of state variables, right? So here if you see number of state variables, they are 2, qa and qb, two state variables are there. So total number of states will be 2 raised to power 2, which is 4, and we represent these states by this, suppose qa qb, right? So the actually this number of states, it will give total number of combination of state variables. So qa qb are state variables, their combinations can be 0 0 0 1 1 1, or let me write it 1 0 1 1, right? So these four combinations will be there, and I will denote it by s0, state s0, state s1, state s2, and state s3. So four states are there for two state variables. Now suppose if we have three state variables like qa, qb, qc, that means for this number of states will be 2 raised to power 3, that is 8. And what are those states? Those states will be like 0 0 1, like 0 0 0 0 0 1 0 1 0, like that, right? This will be s0, s1, s2, likewise it will goes up to s7. Total 8 states will be there if 3 state variables are there. But in this example we have only 2 state variables, so number of states will be 4, that is 2 raised to power 2. Now how to draw state diagram from state table? For that you should first identify number of state. First step is to identify number of states, right? Then make those states or encircle those states. Okay, so write those states. Now connect states using the relation given in table. Connect states. So now I am going to do this. So let me first write, identify number of states. So number of states are 4. Then I have to write those states, and I should write these states in a circular structure, right? So suppose here I write state s0, and what are states? States are, if you see, states are s0 is 0 0, state s1 is 0 1, state s2 is 1 0, and state s3 is 1 1. These are the states, right? I should write these first. Then states are s0, s1, s2, and s3. I wrote these states. You should know what is s0. S0 is nothing but 0 0, means qa is 0 and qb is 0. Okay, so these things you should know, that qa is 0 0, qa and qb, 0 0 is s0, qa qb 0 1 is s1, qa qb 1 0 is s2, q3, like qa and qb as 1 1 is s3. Now if you see from this table, in state 1 1, so I am in state 1 1. Okay, 1 1 means, see, 1 1, qa qb 1 1 means it is state s3. So I am in state s3. I am in state s3. Now in state s3, if I give input x equals to 0, it will goes to state 0 1. What is state 0 1? State 0 1 is this s1. So it will goes to state s1 by giving input 0, and in this process what is the output that I am getting? I am getting output as 1. So what I am doing actually is, in state present state S3, giving input x, I go to next state, and in the process I get some output. So this is the way to write those things. Now if you see here, so I'm in state 0 1 and I'm giving input 1. State 0 1, what is state 0 1? State 0 1 means S1. So I am here in this state, I am giving input 1 and I am going to state 1 0. I am going to state 1 0 means 1 0 means S2, right? So I am going here. I am going here. So arrow will be like this. From S1 I am going to S2, right? By giving input of 1, and in the process I am getting output as 0. Correct? Similarly, if you see this one, I am going from state 0 0 to 1 1. So I am going from 0 0 to 1 1. I am going from 0 0 to 1 1 by giving input 0, getting output 1. By giving input 0 and getting output as 1. So this is the way how you can design or how you can draw state diagram from state table. Now we have two types of state machine. We have two types of state machines. Those state machines are Mealy State Machine and Mealy State Machine. So Mealy circuit or Mealy State Machine is a state machine where output depends only on present state. Output depends only on present state and not on the state that input. It depends only on present state. In Mealy circuit or Mealy State Machine, output depends both on present state as well as on input. So remember this thing. For Mealy, output depends only on present state. For Mealy, output depends on present state as well as input. So here is the block diagram for both Mealy and Mealy. Normally, in any state machine, we have three blocks. One is input combinational circuit, second one is memory element or flip-flop, and third one is output combinational circuit. So in any state machine we will have these three blocks. Now for Mealy state machine, the circuit diagram will be like this. We have input combinational circuit. Output of this input combinational circuit goes to memory element or flip-flop, and remember to add this clock. Okay, this clock, because it is flip-flop or memory element, so clock will be there. Most of the time students got to they forget this clock. Okay, so input combinational circuit will have input to it. It is connected to memory element or flip-flop, and output of this flip-flop goes to output combinational circuit. Output of this flip-flop goes to output combinational circuit, and this gives me the final output. Okay, and remember one thing, from this flip-flop I will take the signal back to input combinational circuit. Okay, so what I'm doing, I'm using the present state, giving it to my input combinational circuit, and using input and present state, because see this is now present state. So from this input and present state, this will generate the next state. So we call this input combinational circuit as next state generator. Okay, next state generator, and here output is something like that next state, set QA plus QP plus that thing. So here output is like next state. Here output is like present state. Okay, this is like QA QB that things. This input is X, this output is Y. So this is block diagram for Mealy circuit, and here output depends only on present state if you see, because input to this output combinational circuit is only QA QB, which is present state. That's why this is Mealy state machine. Next is Mealy state machine. So what is difference between Mealy and Mealy? Mealy's output depends on present state as well as on the input. So it will also have three block diagrams, three blocks: input circuit, input combinational circuit, memory elements or flip-flop with a clock, and output combinational circuit. Okay, so to this input combinational circuit I will give some input x, this output is y. Output from this input combinational circuit is next state. Okay, why next state? Because as in Murray, this memory element or flip-flop, this gives me present state. Okay, so here output is, this output is, this output is present state, which is like QA, QB, QC, whatever, that depends on number of flip-flop or memory elements that we are using. And this present state is going back to input combinational circuit, and from this input x and input this present state we will generate next state. So next state will be like QA plus or QB plus QC plus, like that. Fine. Then output from this output combinational circuit depends on present input x as well as present state. Fine. That's why we call this Mealy State Machine, because output depends on input as well as state. Okay. Now let me give some random example using gate, flip-flop to Murray and Mealy. If you see this circuit, this is some random circuit using T flip-flop, and I have used TA, TB, QA, QB. That means it is having two state variables. It is having two state variables. So 4 states will be there, right? 4 states will be there. That can be S0, S1, S2, S3. Okay. So if you see here, input is A and here input is A bar. Clock is something different, so don't consider that anywhere. Now if you consider this part, if you consider this part only, if you consider this part, so in here we don't have any memory element, we have only OR gate and AND gate. So they are like combinational circuit, and input to this combinational circuit is A and A bar. So this part will represent your, this part will represent your input combinational circuit, input combinational circuit. Now if you see this part, this is an OR gate only, and input to this OR gate is this thing. Okay, and this is nothing but QA, and this thing is nothing but QB bar. Okay, so this is like your output combinational circuit, and output depends only on the states, present states. See, QA and QB bar, they are only present states. So this is a Murray state machine or Murray state diagram, circuit diagram, not state diagram. This is Murray state machine or Murray circuit. Fine, because output depends only on the present state. Now if I want to design Mealy, what I should do? And one more thing is there. If you can see this thing, this part, remaining part, this is your flip-flop part or memory element part, right? Flip-flop or memory element. So all the three blocks are there. Now let's come to example of some Mealy machine. So if you see this circuit diagram, here if you see this circuits, if you use this part, so here I am having AND gate, OR gate, and this is like input combinational circuit, input combinational circuit. And see what is the difference between the previous and this one is that here output Y, it depends on like QA, it depends on QA, QB bar, as well as it depends on output, not output, it depends on input A also. So I just connect this extra line. I connected this extra line A, and A is input actually, right? So now my output depends on present state plus input. So this will give me Mealy machine or Mealy State Machine, and this block is output combinational circuit. Okay, so remaining part, whatever is remaining there, those remaining things will be, this remaining thing will be representing your flip-flop or memory element part. Memory element part. Fine. So this is all about basics of state machine, how to design state diagram from state table, what are Murray and Mealy state machine. If you have any doubt, feel free to contact me. Thank you.